In this video, we will talk about how to plot polar coordinates. So I have a few examples for us to work through here. Let's check out the first one. Let's say we're given the polar coordinates 1, 3 pi over 4. How can we plot these coordinates? Well, we first need to recognize that these coordinates are given in the format of r, theta, where r is just the radius of the circle that this point lands on, and theta is the angle. So first, we need to identify where is the angle 3 pi over 4. Well, if we think about our unit circle, here's 0, here's pi over 2, pi, and 3 pi over 2. The angle pi over 4 would land somewhere over here, like this. And the angle 3 pi over 4 would land somewhere over here, 3 pi over 4. Because if we want, we can think about this pi as a fraction with the same denominator as 4, so we could rewrite this as 4 pi over 4. So 3 pi over 4 doesn't quite reach 4 pi over 4. So this is where 3 pi over 4 would land. So this is the angle. Next, we just need to identify what's the radius of the circle. So over here, I've drawn a few circles with different radius. So for example, this inner circle right here, we can think that to go from the origin to any point on this circle, it's just a distance of 1. So to get to any point on this circle, it's just a distance of 1. So this circle has a radius of 1. So this is the circle that our point will land on because we're told that the radius is 1. And we just said we just identified that the angle is 3 pi over 4. So if 3 pi over 4 extends somewhere over here like this, then we're simply going to plot the point on the circle that has a radius of 1. So right here. That's where 1, 3 pi over 4 would land. Okay, let's try another example. Let's say we're given the coordinates 3, negative pi over 6. So once again, the 3 is going to be the radius, and the negative pi over 6 represents the angle. So if we think about our unit circle, pi over 6, that angle would be right about here. But negative pi over 6, remember when we have a negative angle, we're rotating in this direction around the circle. So negative pi over 6 would be somewhere over here. So that's the angle that we're going to plot the point at, and then we just have to plot it on the circle that has a radius of 3. So over here we said this is our circle with a radius of 1, this one has a radius of 2, and this one has a radius of 3. So we'll use the angle negative pi over 6, and we'll land on the circle that has a radius of 3. So right there. Okay, let's try another one. Let's say we're given the polar coordinates 3, 3 pi. So once again, this 3, this first value represents the radius, and 3 pi represents the angle, or theta. So if we think about our unit circle, if we go all the way around the circle, that's 2 pi. And if we go 1 more pi, so 3 pi total, we will land right here. This is 3 pi. So this is the angle that we'll be plotting our point at, and we're told that the radius of the circle that we'll plot the point on is 3. So our angle is 3, so we're going this way, and the point will land right here on the circle that has a radius of 3. So that's how we can plot that point. Now let's try one more example. Let's say we're given the polar coordinates negative 4, pi over 4. So negative 4 represents our radius, and pi over 4 represents our angle, or our theta. So if we think about our unit circle, the angle pi over 4 is right about here. So that's the angle that we're working with. And we're told that the radius, in this case, is a negative 4. So this one's a little bit different. Let's imagine that it's a 4. So if it were a 4, we would plot it at the angle pi over 4 on the circle that has a radius of 4. So this one right here. But since we have a negative 4, we actually have to go in the complete opposite direction. So we're going to go all the way over here. So the point that we'll plot will actually land right here. So keep that in mind when you're given a radius that has a negative value.